So this is about as zoomed in as I can get it, so you can read along on your paper. It says a dog trainer is fencing in an enclosure. It's represented by the shaded region here. The trainer will also have 2 square storage units on either side. That would be our little dotted, filled-in regions. She can make the enclosure and storage units as wide as she wants, except for no more than 100 feet in total length. So that's what this diagram is showing us. And we've got a few steps here. Let S represent the side length of one of the storage units. And we're going to label those storage units. So just put S's along all these. They're squares. So S is all the same length, but we don't know what length it is. That's why we use a letter, a variable, right? So it can vary, it can change. Check, we did that. And then we're going to write a function right away. I'm going to change this function up a little bit. I'm going to use A of S so that we can come up with not the length, but the area of the enclosure. By plugging in a value for S, the length of the side, we can come up with an area. So area, we're getting to the end of this. This is going to be the last family of functions. So we're getting kind of towards the end of this class. What's your math class going to be next year? Geometry, and you've already had a little bit of geometry, but you're definitely going to be working with areas in geometry. Anybody remember how you calculate the area, what the formula for an area is? I'm going to write this all backwards. I'm going to say area equals width times length. So we definitely want to use that. The length we're going to say is this right here. And the width, so this is going to be our length, and then the width will be this right here. What other variable is that width equal to? Would you say that no matter what S is, W has to be equal to S? They're right across from each other. So we're going to say right away that the width is just going to be equal to S. The length is going to be equal to like 100. Let's say length equals 100, except for not quite 100. What we got to take away from this 100? We got to take away S, and how many S's? Right, there's an S on either side. So if we take this guy away and this guy away from 100, then we end up with the actual length. So I'm going to plug these two things in here. We want area, but not just area, because we want area as a function of the side. And the width here, we can say that the width of the enclosure is going to be the same as one of the side lengths of our storage area. So we can just say, we plug in S there. W, just substitute in S for it. And then we're going to substitute in something for L. Up here, the length is 100. Take away some. So we're going to multiply that times 100 minus 2S. This is a good enough equation, but it would be a little bit nicer if we did not have these parentheses in there. We have to have the parentheses because S is being multiplied by this whole thing, because that whole thing is our new length. How might we get rid of these parentheses here?
Distribute.
We did a little review on distributing, right? So we can distribute. So I'm going to say that A of S turns into 100 times S, right? 100 S. And then what do you suppose S times negative 2S is?
Negative 3x?
If we were adding it, it would give us, or if we were taking it away, it would be minus a third one. But since there's only just one number in here, we can think of there being a 1 out front. 1 times 2S, negative 2S would just be negative 2. But now, what's another way of saying S times itself? We got 2 S's in there. Exactly. So this is the part where we came up with this equation, and we're going to be doing this today. I'll give you a little bit better explanation of how we do it. But now we're going to let Desmos graph it for us. So if I go over here to my Desmos, and this looks a little bit different. We definitely had this part in there, but it was like S's instead, right? So I'm going to actually change it and make it just look just right, S. And it doesn't know how to graph it right now until we tell it the name A and then of the variable S. And now these are all of the ordered pairs that would make this true. So we're going to go ahead and graph this. What are your two x-intercepts? This is the x-axis. What are the two values where our line crosses it? So I'm going to keep these two in mind, 0 and 50. And my highest point is in between 1,000 and 1,500. You guys know what number would the highest point would be?
250?
Yeah, it's got a 125 in it. So I'm going to go ahead and give myself, I've got my side length on the bottom going from 0 to 50. And here we're going to say this is the area. And the highest area was 1,250. And we'll go ahead and draw, as best you can, an upside down U shape that hits X at 0 and 50 and goes no higher than 1,250. So since we're dealing with squares and we got a lot of straight lines here, it seems odd that we would end up with a curve for the line when we graph this. But there's some sense to be made from this. This is our highest point, our highest area that this could be. What would the x value be, or the side length value be, right underneath this highest point? What do you think? Seems like it's symmetrical, right? It seems like this point, if we go straight down, we would get to 25 feet, right? So if we follow this straight across, imagine your storage unit is 1 foot. That would be like this one right here, right? So we would have 1 foot, and it would be extremely small. Our area would be really small. I don't know which one of these three, maybe this one is the biggest. And so you can imagine that this might be a length of 25. So when our side length is 25, then we have the biggest area here. But as soon as we start getting bigger than 25, if this is 30, if this is 40, then if we go over to 40 and we go up, you can see we have a skinnier, smaller area. So there's a sweet spot that's kind of in the middle. And generally, it's the bigger the area, the more close it is to a square. When we start making a rectangle out of it, whether it's a really long rectangle or a really wide rectangle, then our area starts to decrease. So we can use this quadratic graph to compare the length of one of the sides to the whole area. which is what we're going to do in part 1. All right, so it says write a quadratic function in standard form. That we're going to cover at the very end. We're going to have to solve for area plugging in the width. And so before you even read any of these, start off by giving yourself what the area is equal to. Area equals width times length. And you might have to write kind of small. I should have given you guys a little more space for this. But we are going to start with 2 equations. This is the first one, always this one, which is literal, no numbers. And now we're going to pick out some numbers here. We have 30 feet of fencing that's going around our parking lot. And how many sides of the parking lot are we going to enclose? So these are the 2 numbers that we're going to use. So our second equation is going to be talking about the length of the fence, which is going to be 300 to start off with. And if there's 3 sides, that means we've got 2 widths. We've got a width over on this side, and we've got a width over on this side, and then we got a front. And I'm thinking the back of it, it's up against the store or whatever, so we don't have a back. But we're going to say we have 2 widths, 2 times W. So we've got the W over here, and we've got the W over here, and then we've got the front all the way across is 1 length. So hopefully that makes sense. If we take this width plus this width, that's 2W, and we add this length, then that should give us 300. After this one, then you can go. In the meantime, be writing down what's going on up here. It's pretty in-depth, and you guys are going to be asked to do this on your own after a couple of examples. So the first thing that we're going to need to do is get this L by itself. Isolate it. Write this down. Isolate the L. What's keeping the L from being all by itself on one side of the equation? How do we get rid of the 2W?
Divide.
Not quite. What's the opposite of? So it's being added, so let's go ahead and subtract it away. Take it away from this side as well. And can we take it away? Well, and it's not a like term, right? If this was talking about the number of, if there were 300 W's and we take away 2 of those W's, we could subtract it. So really, since these are not like terms, the best we can do, let's just go ahead and write negative 2W plus 300. That's the best we can do. Since they're not like terms, we cannot combine them. So these 2 terms turn into that. And what are those 2 terms equal to? We got rid of the 2W, so all that's left on this side of the equal sign is the L. After we have isolated the L, we're going to sub into other equation. It already has an L. What we're going to substitute in is what L is equal to. So I'm going to go ahead and write that other equation. A equals W. And what's L equal to? It says right here, we just found out L is equal to all of this. So in place of this L, we're going to say A equals W times negative 2W plus 300. So there's 2 key steps here. Getting the L by itself, isolating it, and then substituting in what L is equal to into our original area formula. The very last thing I had you guys practicing with, how would you get rid of, last week you were practicing with it, how would you get rid of that parentheses there? When these are not like terms, we cannot combine them. So what we can do is multiply what's outside the parentheses by both things on the inside. We'll say A is equal to, again, when there's no number that this number is being multiplied by, if there's no number across from it, that number stays the same. And this is where it turns quadratic, because W times W is W squared. Let's see here. What about W times 300?
300W.
Yeah, make sure you put the number first, 300, and put the W behind it. We always like to put the number first, then the variable. So this looks complicated, but as long as you took good notes, you'll notice there's not really any math going on here. We said we were doing some subtracting, we couldn't combine like terms. We said we were doing some multiplying, but we didn't really multiply, none of those numbers changed. So it's really about rearranging the information we're given and being able to put it into a formula like this. Do you guys want to do another one on your own, or you want to try one of these on, or you want to try one on your own, or do you want to do one together?
Try one.
One more together. I'm a little tired of listening to myself talk, so I imagine I'm stretching your guys' attention, but I guess we can work up some endurance, right? So I'll ask you guys to take good notes through this one. You take good notes, and like I said, it's not a lot of math, but being able to follow the process is key. Before we even read it, what equation that's nothing but letters can I give myself? Nothing but letters. What equation did I start off with on the other problem?
Multiplication.
I heard it over there. A equals width times length. Now I have to pick out a couple numbers up here. How many feet is this fence?
40.
And how many sides do you suppose this fence is on? There's a flower garden. They're keeping out the rabbits.
4.
And it doesn't say, so when it doesn't say, then we're going to make it a regular rectangle, 4 sides. Let's go ahead and use these two numbers to come up with the next equation. Which one of those do I start with, the big number or the small number? Let's start with the one that they put out as a number, right? That one that's actually a number instead of the number of sides. Let's start with the 40. And that's going to be equal to some combination of the sides and the front and the back. Let's call the sides the width. How many widths do we have on the sides? We got 2 sides, right? So let's go and say 2W. And this one, since it's 4 sides, how many lengths are we going to have? Plus 2L. Let's see here. We've got 2 equations. We came up with, this one's always going to be the same. We came up with the second one. And then I pointed to one of these parts of this equation. I told you to isolate it. What are we isolating on that second equation?
2L.
So we're going to start off by isolating the 2L. And you're going to be doing the same thing on every single one of these. What are you going to do to get that 2L by itself?
Subtract 2W.
You're going to, every single problem that you're working on today, you're going to take away 2W. Is your first step after you've come up with your 2 equations. Put minus 2W on the other side. And let's go ahead and now combine this together. Let's rewrite it as negative 2W plus 40 equals
2L.
2L. There's not a 2L in our original area formula, right? So we cannot just plug in this unless we get rid of this 2. So we got to continue isolating. How would you get rid of this 2 in front of the L?
Divide.
Yeah, there's multiplication happening between them, right? And division undoes multiplication. Since we did it to this whole side, we cannot just do it to one of these. We have to do it to this whole side also to keep it equal. So, like I said, we're not just dividing negative 2w by 2, we're also dividing 40 by 2. Let's start with this one, though. The numbers. What's negative 2 divided by 2?
Negative 3.
Subtracting would be a negative 3. Not even. What's anything divided by itself? So, anything divided by itself, and then negative divided by a positive is a negative. And what do I put behind the 1? We did not divide that w out. If there's a w down here, it would have canceled out, but we need that w in there. And then divide this one. What's 40 divided by 2?
20.
And we finally got the L by itself. So we isolated first. Once we got the L by itself, then what did we do? Plug it in. And before I pointed to the L and I said substitute, but it would be more accurate to point to this and say substitute. We're going to go back to our original equation, and we're finally going to use this. We're going to substitute it in for L, so we're going to say A equals W. And what are we multiplying instead of length? What are we multiplying W by?
Negative 1w plus 1.
Yeah, since it says that all of this is equal to W, then we can plug it in for, is equal to L, we can plug it in for L. And our very last step, what did we do to get rid of the parentheses?
Distribute.
And you can go ahead and get rid of, if you multiply something by a negative 1, the 1 is gone. It just turns into negative W. So this is going to turn into negative W squared. You could keep that 1 in there if you wanted to, since it's the only number in there. Multiplying something by a negative 1 just turns it negative, though. And then W times 20, what do I write that? How do I write that like?
Plus 20w.
Plus, keep the number first, variable last. All right, take a look at number 3 on your worksheet. And this looks impressive. This looks complicated, what we just did. But we didn't hardly do any math at all. We did a little bit of division. And all you're going to do for number 3 is you're going to change the number 40. So you're almost going to just copy this exactly, but put in, I think they give you 100 instead of 40. Go ahead and follow this process and see if you can't come up with the answer that's on the back of your notes. Go ahead and take a look at number 3 and see how you can do on that. So you got your notes probably on the left side if you're right-handed, and just looking at what we just did, and then follow the same process on your worksheet.